In this video, we're going to learn various ways to find the angle measures in the triangles. Here are some important concepts. Corollary. A corollary is just an extension of a theorem. If we already know a theorem, then there are different ways of extending that to make that theorem even more useful for us. And sometimes it makes life a lot easier for us. Interior angles is what everybody is accustomed to. If we have a triangle, let's say if I have a triangle ABC like that, ABC, and all these three angles inside the triangle are exterior angles. Are interior angles because they're inside the triangle. Now, if I extend one of the sides, any of these three sides can be extended, right? If I extend one of the sides, and you can even extend that line AC on both sides. Once I extend it, you notice that my black ink covers an angle that's outside the triangle. But this part, the black part, is adjacent to the interior angle C. So I'm going to call this C prime, maybe. And that's called exterior angle because the angle C prime is outside the triangle, but it's adjacent to an interior angle. And as you can see, you have to extend one of the sides in order to find that exterior angle. Okay? Here is a very important theorem called triangle sum theorem. It says that the sum of the measures of the angles of a triangle is 180 degrees. In other words, if we add all the interior angles together, angle ABC together, you should have 180 degrees. And here's an example. In this example, angle A is 35 degrees, angle B is 85, and it's asking you to find angle C. And since we know that angle ABC together, if I add them together, the sum is 180 degrees by triangle sum theorem, then I just use substitution. I already know that angle A is 35 degrees. I already know angle B is 85 degrees. And then I do some algebra, you should be able to find out that angle C is 60 degrees. And that's our answer. Again, the important thing here is we use the triangle sum theorem that all three angles adds up to 180 degrees. Here is an extension to that theorem. The acute angle of a right triangle are 90 degrees. So look at the example here. We have a triangle ABC, but C is a right angle. In other words, if this is already 90 degrees, and I know that the measure of angle A, measure of angle B, and the measure of angle C has to add up to 180 degrees based on the triangle sum theorem. And if I just substitute angle C with 90 degrees, then I draw the conclusion that angle A and angle B have to add up to 90 degrees. Right? I subtract 90 from both sides. That's how I got my answer. Now let's see how we can use that. Angle ABC and angle BDC are right angles. So we have two 90-degree angles there. Suppose angle measure ABD, which is the small angle right here. This part is 35. And we need to find the DAB, which is this angle here. How do we approach that? We know that DAB and ABD have to add up to 90 degrees, right? That's because of the corollary to the triangle sum theorem. Angle DBA and ABD is 35 degrees. So angle DBA plus 35 has to equal 90. We just did a substitution. And now if I subtract 35 from both sides, so I should have angle DBA has to equal 55 degrees because I just subtracted 35 degrees on both sides. Okay, in the first half of this video, we dealt with the triangle sum theorem. So they were all about the interior angles. If you add all three interior angles, doesn't matter what kind of triangle it is, the angle measure has to equal 180 degrees. Now we look at an important theorem that deals with the exterior angle theorem. It says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So in our example here, they extended the line AC, and angle 1 is an exterior angle. So this theorem states that angle 1 equals the angle measures of A and B together, the sum of that. Notice that you have to leave C out of it. Oops, I forgot that measure. So measure of angle A and measure of angle B added together, that should equal the exterior angle measure. So the reason for that is, let's call this interior angle, I'll use a different color. This interior angle here, let's call that C. So notice that the angle measure of C and the angle measure of 1 has to equal 180 degrees because 1 and C are supplementary angles, right? Now we're starting to add chapter 2 and chapter 3 materials together. So again, angle C and angle 1 are supplementary angles, so they add up to 100 degrees. We also know that angle C plus angle angle A plus angle measure of B has to add up to 180 degrees, and that's by the triangle sum theorem we just learned, excuse me. And because these two are exactly the same, we can draw the conclusion that these two are the same. So angle measure C plus angle measure 1 equals angle measure C plus angle measure A and angle measure B. And if we cancel angle measure C on both sides of the new equation, we draw the conclusion here that right here is our equation that written vertically, that angle measure 1 equals angle measure A plus angle measure B. So that's how we came up with this angle theorem. That's the proof of the theorem. Let's see how we can use it. In this triangle, we have angle measure A at 58 degrees, we have C at 72 degrees, and we need to find angle measure for the exterior angle 1. And by exterior angle theorem, we know that angle measure 1 has to equal the sum of the two non-adjacent interior, which is A and C. And A, like we said, is 58 degrees, and C is 72 degrees. So check my math there. I think if you add it up together, it's 130 degrees. That's how we use it, okay? So again, please review the two important theorems and do your practices. This is really, really important. You're going to see these theorems being used in calculating angle measures again and again. Thank you, guys.